lecture. My privilege to introduce first speaker, Professor Y. Shu. He is the lecturer at the State Laboratory for Chemistry and Molecular Engineering of Medicinal Resources, College of Chemistry and Pharmaceutical Sciences, Baoshe Bawal University, in China. His research interests include isolation and structure dissipation and structure activity of biologically active natural products. And today he will present his talk entitled Alkaloids from Punjab. So over to you, Dr. Shu. Can you hear me, Dr. Shu?
Yes. Can you hear me?
Yes, we hear you. You can start your presentation now.
Okay. I start. It is my great honor to have this opportunity to present our work in International Symposium on Natural Product Chemistry. The topic of my talk today is alkaloids from two fungi. My presentation mainly includes the following parts. Background. About 1,040 small molecule drugs have been approved in the past 40 years, of which more than 400 natural products and derivatives, about 1/3, combined with synthetic drugs associated the natural pharmacophore and mimic of natural products, the total is more than 2/3. So natural products are the best option for fighting novel agents. This section consists two representation jobs. The first part is about the investigation on the secondary metabolite from a softer color derived as polyps fungi under the guidance of mass-based molecule networking until separation and absolute configuration determination, in particular, differentiate the natural products and artifacts. First, a molecule network of the extractor of a softer color derived as aspergillus fungi was generated according to mass spectra and visual in SADCAPE. By detailed comparison of the LC mass and molecule networking outcome with the corresponding UV spectra, a small cluster of compounds was targeted, and various column chromatography was used in the isolation of new compounds 1 and 2. Similarly, the plan structure of 1 and 2 were elucidated on the basic of comprehensive spectroscopy analysis, such as HI-ESR 1 and 2 dimensional NNI, and further confirmed by X-ray diffraction data. Compounds 1 and 2 display a layer also has phenylalanine residue. Previously, there are only 8 natural occurring molecular products containing an also phenylalanine lethal, and they are all cyclopeptide compounds 1 and 2 at the first molecular natural product with the lethal. Compounds 1 and 2 contain 1 kilocarbon and should be expected to be triller. However, the base ECD curve and the low spectral rotation so that 1 and 2 were mismatched. Moreover, the central symmetrical space group from the X-ray diffraction analysis further confirmed the presence of mismatch. The antimer plus this 1 minus this 1 plus this 2 and minus this 2 were about on a chiller phase column. The theoretical ECD spectrum of sorting R this 1, sorting S this 1, sorting R this 2, and sorting S this 2 were calculated by the DFT method and compared it with the experimental spectra to determine the absolute configuration of carbon sorting in 1 and 2. Thus, the absolute configuration of minus this 1 and minus this 2 were determined as sorting R, and plus this 1 and plus this 2 were determined as sorting S. The related compound also glycine tryptophan was also isolated as a racemate. Plus 40 R also glycine was assigned as the natural compound based on comparison of the ECD curve to that of 40 R glycine, which the absolute configuration was not determined in the origin literature. Vivian Amanda M was assigned the sorting S configuration after acidic hydrolysis release L phenylalanine. However, a theoretical investigation strongly implied that the collector configuration of Vivian among M should be sorting R. Thus, experimental support for a natural configuration is still needed. We conducted a verification experiment to differentiate the natural product and artifacts. During the iteration process, the fermentation solid medium was extracted with it for 12 hours to give a fresh organic extractor and then prepared by reverse phase HPLC to obtain 1 and 2 in 1 day. Compounds 1 and 2 were then analyzed by in anti-selective HPLC, and plus 1 and plus 2 were detected as the major ones. So the plus this 1 and plus this 2 were considered as the natural product. Furthermore, a racemation of plus sorting S this 1 and minus sorting R this 1 under acidic and basic condition was also studied. When the plus sorting S this 1 and minus sorting R this 1 were each treated with the basic methanol at long temperature, racemation increased. It is very interesting that the racemation of plus sorting S this 1 was suppressed by the addition of the acetic acid or trifluoroacetic acid in methanol with no detector minus 13 hours days 1 after 24 hours. The second part is about the investigation on the sampling alkaloids from penicillin fungi, the absolute configuration determination. In particular, investigation on the difference cotton effect of these alkaloids, the antimicrobial activity were also studied. First, the two new sampling alkaloids together with selenium analogs were isolated from the rice culture of penicillin fungi by chromatographic column. The bright light of the compound revealed that the alkaloid possess a large pair conjugate system. The blend structure of the new compounds were elucidated by spectroscopy methods. Because of the two chiller carbon in the compound are far apart, their related configuration should not be determined by noisy correlation. Previous studies showed that the absolute configuration of carbon 7 of the alkaloid could be determined by CD spectra. If there are negative cotton effect at 380 nanometer and positive cotton effect at 300 nanometer, the absolute configuration of carbon 7 should be S. Conversely, the absolute configuration of carbon 7 should be R. So the absolute configuration of carbon 7 of compounds 1 and 2 were assigned as R according to their CD spectra. Further detailed analysis of the CD of compound 1 to 4 revealed that the CD spectra of compound 2 saw an upside cotton effect at 245 nanometer compared to compounds 1, 3, and 4. So what account for the negative cotton effect at 245 nanometer of compound 2 is the absolute configuration of carbon 13. We next set out to determine the absolute configuration of carbon 3. The absolute configuration of carbon 13 was assigned by semi-synthetic method. Compound 1 and its isolate derivative 7 were prepared from the major product compound 5. With malamine, natural product 2 was from via methylation reaction of 7. Analogs 3 and 6 were also prepared from 5 with ammonia water. The absolute configuration of carbon 13 of 1 to 3 were determined as 13S. By comparison, the natural and synthetic compound CD spectra. Simultaneously, the upside cotton effect at 245 nanometer of 2 was not induced by the absolute configuration of carbon 3. Further comparison of the CD spectra and the structure of compound 1, 2, 4, 6, and 7 revealed that the cotton effect at 245 nanometer is affected by oxygen substitution. Thus, care should be taken in the simplification of data. The antibacterial activities of the sulfurone alkaloids against the bacillus subtilis palatiphiles bacilla and Staphylococcus aureus were evaluated. Compound 3 exhibit potential activity with approximate effect to the positive control ciprofloxacin. Preliminarily, such activity relationship show that the nitrogen 2 contribute to the activity. The acetosis groups have a positive effect on the activity, whereas the substituents at nitrogen 2 have a negative effect on the activity. All the compounds were also evaluated in the in vitro for anti-plant pathogenic fungi activities. The result indicate that compound 3 inhibitory activity against all test fungi with the MSC values ranging from 12.5 to 50 microgram per milliliter by 96 microgram measure. The inhibitory activity to the exoheron twism were further confirmed by radial glucose assay. Conclusion: two new alkaloids less matter featuring a layer also hydroxy lalanine residue were isolated and established. The natural product and artifact were successfully differentiated and provide critical insight into the isolation and identification of natural product. Two new sulfurone alkaloids were isolated and their absolute configurations were determined by CD spectra and synthesis. The quartile effect and 245 nanometer is affected by oxygen substituents of carbon 7 in compounds 1, 2, 3, which reminding that the simplification of structure should be cautioned when calculation ECD of compounds. Compound 3 is inhibit potential antibacterial activities. I thank Professor Shao Changlun, Professor Yang Yueyun, Dr. Cao Rong, and Master Huang Lili. That's all. Thanks for listening.
Dr. Shi for such a nice presentation. So floor is open for one quick question. So if there is no question, I have a question, Dr. Shi. Could you kindly let me know that which chiral stationary phase you used to separate the enantiomers? Which column you used for HPLC separation of enantiomers? I'm asking that which column you use for the separation of enantiomers of HPLC. Dr. Shu, can you hear me? Can you hear me? Okay, thank you so much.
combination of radiation drugs with the nanoparticles that are also being exposed to potentiate the effectiveness of MDR bacteria. So management of the antibiotic resistant bacteria. Antibiotic resistance happens when germs like bacteria develop the ability to defeat the drugs against to kill them. Antibiotic resistance can be either plasmid mediated or maintained on the bacterial chromosomes. This bacteria have become resistant to many antibiotics, so it can be targeted by alternative methods. There are different various methods for the isolation of nanoparticles from the green leaves or from some other materials. So we are going for synthesis of nanoparticles from the biological samples, that is the plant leaf from the porcelain. Significance of this work is these nanoparticles are synthesized from the green leaves of porcelain, and by the green method, this is a very safe method and very rapid and also low cost method. So we apply this method for the isolation of these nanoparticles. So aims and objectives of my work are isolation of nanoparticles from the green leaves, and then we have to characterize the isolated and synthesized nanoparticles, zinc oxide nanoparticles by different techniques like UV, XRD, FTIR, and SEM. And at the end, the isolated nanoparticles, zinc oxide nanoparticles, were applied to check their biological, their antibacterial activity. So we collected leaf samples from area of our Kharagpur, local area of Kharagpur. We dried the leaves at room temperature and then powder. Then extract was prepared in the deionized water. So this is a very common method for the synthesis of zinc oxide nanoparticles from the salts of sodium zinc acetate. So this is the procedure for the synthesis of zinc oxide nanoparticles from the zinc acetate, and this is the final product from zinc oxide nanoparticles, which we are going to apply on, which we are going to characterize first and then apply. This is the collection of the culture for antibacterial activity. So in order to check the antibacterial activity of zinc oxide nanoparticles, two bacterial strains were collected from the GIMS, Government Institute of Medicine Sciences Hospital, Gambhar, and we checked on the gram positive and gram negative E. coli and SUVs. So these are the culture plates. These are the manufacturing of the glycerol broth and the standard solution. These are the assays for the antibacterial activity of zinc oxide nanoparticles. Now this is the whole procedure for preparation of for the application of the zinc oxide nanoparticles to check the biological activity of zinc oxide nanoparticles. Now coming to our results. So there are certain parameters for each and every metal ion or for each and every nanoparticles to check that they are to perform or not. So this is the UV graph. Clearly, the peak at nearly about 378 is very clear, and this is the peak showing that the zinc oxide nanoparticles are successfully synthesized, and this peak is very comparable with the other literature present in the literature, other peaks presented to the literature. There is another parameter to characterize. This is FTIR spectra. Obviously, the range of metal and oxide is between 400 to between 400 to 500 or 600, 600 to 400. We have a clear sharp peak over here, and this is showing the formation of zinc oxide nanoparticles. This is zinc acetate. There is no any sharp peak in this range, but here we have after synthesis of zinc oxide nanoparticles, we have a clear sharp peak at about 400 something nearer to 500. So this is the EDX. EDX is showing the presence of oxygen, and here we have the oxygen. It is also present, and there is the zinc. This is for the zinc 78, and this is about the oxygen, presence of oxygen and zinc. And now coming to the XRD. So clear sharp peaks. These are the characteristic peak of zinc oxide nanoparticles, in which we can clearly see that there is a very small impurity here, but mostly the peaks are very clear, showing that the crystals have been formed. Zinc oxide nanoparticles crystals have been formed. This is the SEM images, which shows that the shape of the zinc oxide nanoparticles is spherical in shape. Mostly they were formed in the spherical shape, and by applying the Schrödinger equation, we can get the size of the nanoparticles, and in our case, it was 24 nanometers. Now, when it was confirmed that successfully we have synthesized the zinc oxide nanoparticles, then we are going to check or apply for its anti-material activity. So we have gram positive and gram negative. In case of SU rays, we have the 12 millimeter zone formation, and in case of E. coli, we have the 6 millimeter zone formation. So it is more effective in case of gram positive, but it shows the activity positive effects on both. So this is the MICSA of both gram positive and gram negative. These are the agar plates for both positive and gram negative. Now we have the minimum inhibitor concentration and the minimum bacterial concentration. Inhibition concentration in case of X gram positive, we have 250 and E. coli 500. And in the same way, we have 500 in case of minimum bacterial concentration was found 500, and in case of E. coli, we had 1000 approximately. Coming to the conclusions, by all the characteristic techniques, UV visible, FTIR, SEM, all the characteristic peaks appear shows that the zinc particles, zinc oxide nanoparticles are successfully synthesized, and their sizes were confirmed, their structure was confirmed by FTIR peak at about nearer to 500, like nearer to 300 in UV, and also the EDX showed the presence of the zinc and oxygen, and in the same way, SEM showed the spherical structure of the zinc oxide nanoparticles. So all confirmed that the required assignment of synthesis of zinc oxide nanoparticles had been accomplished, and after characterization, we can say we applied all these on the gram positive and the gram negative bacteria. In both cases, we found the positive results. Both the extract was effective. On gram positive, it has more effect, and it was also checked that it was more effective than the standard available in the market. So we can say that at the end that zinc oxide nanoparticles might be a good alternate to develop antibacterial agents against the multiple resistant bacteria. Thank you.
Ma'am, what kind of interactions taking place between nanoparticles and
No interaction directly, we are synthesizing something from there. The plant extract we are using as a precursor. Then by this, the other functional groups are also playing a lot of part for as a reducing agent. We are using the salt. So we have to convert the size of the zinc particles, better zinc metal ions specific to that plant leaves. We have to convert them into the nanoparticles. They are already existing. It is confirmed by reported in the literature. There is a large amount of zinc available in this plant, and we are converting the large size of zinc oxide particles into the zinc oxide nanoparticles.
Thank you. So if there is no question, please. For the last lecture of this session, I have an announcement from the organizers. A sightseeing tour has been arranged for our foreign delegates. The wedding will depart at 6:30 p.m. sharp from the guest house. So kindly gather before time at the guest house reception.